Welcome to tonight's meeting, which is all about the evolution of planetary rovers, presented by Dr. Ezzy Pearson. Right, so just want to go through a few notices about tonight's meeting, and then we'll have the main presentation, followed by a planetarium visit with Richard. The eagle-eyed among you will notice that there's no news this time. Len hadn't anything prepared for this time. Nothing significant happened. I think he was going to talk about SpaceX, the Falcon 9, but I don't think anything happened worth note. So just a few notices. We are recording this meeting, so be careful what you say and do. Suggest you use the speaker view so that you maximize the viewing area of the presentation screen. It's the best way to view the actual presentations, in my opinion. Questions, yeah, if you've got questions, you can enter them via the chat at the bottom of the screen. We won't generally answer the questions until the talk is finished, but we'll try and pick up everything then. And of course, you'll have a chance to actually ask in-person questions with your voice and video at the end as well. I want to tell you then about our next meeting. So our next meeting is on the 28th of May, and it's actually our AGM. You might remember that because of COVID last year, we didn't have an AGM. We didn't have a Zoom license at that point. So it's really important that we hold the AGM this time, and I hope you can all attend that. So the 28th of May will be our AGM. We'll also have members' images in that meeting. And if you have contributions you wish to make to that, let me know a few days in advance of the meeting. So I need about 2 or 3 days to put the presentation together and get it all lined up. So around the 25th, 26th of May, send in any images you've got to me. Here's some from the last members' images that we had at Christmas. With that, because there is no news, I'm going to ask Izzy to take over in a minute. Just a very short introduction about Izzy. She's going to talk about the evolution of planetary rovers, as we said. She is an astronomer and an author, and she has published a book called Robots in Space, available from all good news agents and larger vendors as well. She's a news editor for the BBC Sky at Night magazine and presents its monthly podcast, Radio Astronomy. She's got a PhD in galactic astronomy, and she's very well placed then to talk about these things. But basically, it sort of covers the talk from the earliest to the latest rovers. So I actually particularly like the little back note on her book, which is one small step for a robot, one giant leap for mankind. Thought that was a good take on Neil Armstrong's line. So with that, I'm going to stop sharing and hand over to Izzy.
Okay.
And once you get started, I will mute mine.
Okay, so can you all see that now?
Yes.
Good, great. Hello, thank you very much for having me on today. So yes, as I was very ably introduced, I am Ezzy Pearson, and basically I am a professional space enthusiast. I get paid to tell people how brilliant space is, which I'm sure is not a very hard sell with the current audience. But there is one area of space and space exploration that I've always found particularly interesting and particularly fascinating, and that's planetary exploration, specifically exploration that has gone out and actually made contact with another world. I just think that's such an interesting and kind of the fact that we've managed to touch another world, whether that's a planet or another planet's moon or even our own moon. And there are, basically speaking, 4 kinds of types of missions when it comes to exploring the surfaces of other worlds. You can have an impactor mission, which is literally you smash something into the surface of another planet and see what gets kicked up, or see how big of a crater you do. These tend to be the kind of simplest, the first types of exploration that happens with planetary bodies, just because they're the easiest. You don't have to worry about landing. Then things get onto the static lander. So here you have a picture of, this is the Venera probe, which descended through Venus's atmosphere. And these are ones where they come down onto the planet's surface and just sit in one place and do what they're going to do. The next step up in complexity is mobile missions. Up until this point, those have largely been rovers. This one is Curiosity. And those have been the ones that have gone around and explored other worlds. Finally, your most complicated type of planetary exploration is human exploration. And in fact, this is so complicated, we've only done it to one place. We've only ever explored the moon with humans. And if we're honest, it looks like that's going to be a case for a long time yet. But I'm going to concentrate today on that third category, the rovers, the ones that have moved around the surface. Now, why are rovers so brilliant? Well, rovers have a very good thing going for them, which is that obviously they can rove, they can move. And this is important because there is this constant tension in spaceflight and planetary exploration between the scientists who want to go somewhere interesting and the engineers and the people building these spacecraft who want it to go somewhere safe, where it's not going to hurt itself. So here we have, on the left, we have the nice flat plane of Gale Crater, and that's where Curiosity put itself down. It's a nice flat plane. There's nothing dangerous that's going to hurt your rover when you're trying to land. It's a good, safe place. Unfortunately, from a scientific perspective, it's quite boring. There's nothing much interesting there. It's flat. But because you're a rover, that means once you've landed, you can go over to the right-hand side and these big, sharp, spiky, scientifically interesting rocks. And so that's exactly what Curiosity did and is doing. Because could you imagine trying to actually land a rover on something that looked like that? You just wouldn't do it. It just wouldn't happen. And so this is one of the reasons why rovers are so good. You can get into really nice, interesting areas that you would just be too dangerous to land on straight away. But I'm getting ahead of myself talking about Mars, because the first place where we actually sent rovers is the moon. So taking you back right the way back to the 1970s. So at this time, the space race was pretty much over. The US had won. The Russians, the Soviets had realized they were never going to be able to put a human on the surface of the moon. Apollo had already landed. So instead, what they thought they could try to do was change the conversation a bit. Rather than being, we've put another human on the moon, it was more, they wanted to make it a question of, we can do everything that the humans could do, that the Apollo missions could do, but we did it with robots. That's what the Soviets tried to do. And they had two main avenues for this. They had the lunar missions. Lunar 16, 20, and 24 were sample return missions. So they touched down on the surface, scooped up some rocks, and then sent it back to Earth. It wasn't as much as the Apollo astronauts, but it was something that they were able to do. But most importantly to this talk, the other thing they did was they sent their own lunar walker, moon walker, except in Russian, moonwalker is Lunokhod, and this is the Lunokhod rover. There were two of these sent to the surface of the moon, and they are basically the first ever planetary rover that got sent, and they were basically humanity learning how to build and rove on another world. They have all of the basic things that we now put onto the rovers even today. So what are those things? Well, there's kind of 5 basic areas that you need on any roving machine. You need to have power. So in this case, you can see that there's kind of like a kettle lid. That's what they tend to call it, that the big body is called the kettle, and then that's the lid on the top. And that actually has a solar panel on it, which in this picture is closed. This, by the way, this rover is about 1.5 meters high. It is not a small thing. It was taller than me. It's a big one. But it had a solar panel on that lid, and that was what generated its power. Then you have something called the warm electronics box. It's brains, basically, where it kept all of its instruments, all of its power, batteries and things, all of the things that it needed to actually work. And they tended to be kept at room temperature and pressure, because it's much easier to make a box that's at room temperature and pressure than trying to work out how to make electronics that will work in a vacuum of space. Then you need to have some kind of motion. And in the case of Lunokhod, what they settled on was 8 wheels, 4 on each side. Each one of these could move independently. They could be jettisoned off in case one of them got stuck. They looked quite flimsy on Earth, but because, especially, you know, trying to hold up something that big, but because on the moon there was much lower gravity, the rover had absolutely no problem rolling around on these very flimsy looking wheels. Next, you need to be able to look around. I mean, there's not much point sending a rover to the moon if you can't see where you're going or you can't look at anything to do any science. So it had eyes, 2 cameras, which you can see here as the black dots on the front. And then finally, you need some way to communicate everything that you can see back to Earth. So you need to have some kind of communications. So those are basically your 5 basic things for building a rover. Then, of course, most people also want to actually do something with the rover when it's there. And so there's usually a couple of scientific instruments strapped on as well. In the case of Lunokhod, it was mostly concerned with looking at the composition of the lunar surface. And it also had a couple of instruments to basically give the lunar regolith, the lunar soil, a good poking to see what it did when it was actually under the conditions of the moon rather than in a lab back on Earth. So that is your basic Lunokhod rover. And of course, you had to be able to get your rover onto the surface of the moon. And they did this with the Lunokhods by mounting the rover onto a platform. And then the platform had all of the thrusters and stabilization things. It was concentrating on doing all of the tricky bits that come with doing a soft landing on some place like the moon. Had some ramps that the rover could then roll off and leave all of that complicated machinery behind. And that was how many rovers get to the surface. So this was the first image, one of the first images sent back by Lunokhod 1, which made it to the surface in November 1970. Now, you might be able to see from this image, it's not terribly good. It's very grainy, it's filled with lines. You can pretty much only see the brightest white places. It's not grayscale, it's pretty much just black and white. And this was a problem because this was what the drivers were using to navigate by. So because the moon is only, I think it was 3 light seconds away to get the signal there and back, they were piloting these rovers on the surface of the moon in real time. But they were doing it with these images, and this image was only coming through once every 30 seconds. So just, can you imagine trying to navigate with this picture only coming in every 30 seconds? It was incredibly, incredibly difficult. The drivers did not have a good time with it. Added to that with the stress of people, you know, a lot of military commanders who didn't really know what they were talking about would come into the control room and sort of say, oh, don't crash. And so the first couple of months that they were driving on the moon was very, very stressful for the drivers. And eventually all of the military people got kicked out and they were allowed to get on with their job. And they started, actually, they got to grips with motoring across the surface of the moon. And in fact, they got a little bit too good at that job. As I said before, the drivers and the engineers, the people looking after the rover itself, didn't want to risk it getting hurt, which meant when the scientists said, oh, can we look at that big dangerous rock over there? The drivers would quite often say, no, you might hurt the rover. This wasn't helped by the fact that Pravda, the Russian state paper at the time, was constantly publishing a log of how far Lunokhod had gone that day. And there was this big war of, we've got to keep going, we've got to keep going. In fact, the head of the institute which ran Lunokhod is reported to have saying it's called Lunokhod, Lunar Walker, not lunar stop. And this was very frustrating. You know, they'd sent this incredible science machine to the surface of the moon and they weren't allowed to use it to do science. Fortunately, the scientists did eventually manage to convince the higher ups that, you know, we should go and have a look at those rocks. And they did begin to start doing a bit more scientific exploration. The rover eventually lasted for 10 lunar days, so 10 months. It was because the rover drove around during the day and then rested and overnight, and then would come back during the day when it could charge its solar panels. But unfortunately, when it woke up on the 11th day, something went wrong. There was a sudden pressure drop inside its warm electronics box, and it just died. But in that time, it had managed to go 10.5 kilometers. Now, fast forward to 1973, and the Soviets had another go at landing a rover on the surface of the moon. They'd learned this time. They'd worked out perhaps they might want to have a bit better cameras. So these have been zhuzhed up a bit, these pictures, but as you can see, they are much higher resolution. There's a lot more different colors that you can see. And most importantly, the feed renewed every second rather than every 30 seconds. It was a lot more easy to navigate. And despite the fact that Lunokhod 2 only survived half the time that Lunokhod 1 did, it only lasted 4 lunar days, it managed to go 39 kilometers across the surface of the moon. It went a huge distance. And also at this point, tensions between the US and the Soviets were beginning to thaw a bit. So there was a bit more collaboration between the two. And in fact, the Soviets managed to use some of the pictures of this mountain range that you can see along the bottom. By the way, the picture has mountains sticking out at the bottom and the craters at the top are going into the page. I find it's one of those like weird magic eye things, and it's sometimes quite hard to see which way things are going. So just to clarify that. But anyway, this mountain range at the bottom was photographed by Apollo 17, who had flown over not long before. And so they could use these pictures to kind of work out where they were going and have a look around the surface. And it started at the top, came down to the mountains, drove along the mountain range for a bit, and then ended up at this rill, which is basically a big canyon on the surface of the moon. Drove along the edge of that rill, and unfortunately, at some point, the solar panel touched up against the wall, got dust into the radiator, and it overheated and died. Unfortunately, the engineers were right. They got too close to something interesting, and it killed the rover. It's unfortunate. Dust, as we'll find out, is not a rover's friend. But these were two incredible machines. They taught us an incredible amount about what lunar soil acts like on the surface of the moon. They also taught us that it's incredibly difficult to drive about in the lunar regolith, the lunar soil, because it's basically made of tiny little razor blades. It's thick, it gets into everything, and it's quite difficult to work with. It's one of the biggest issues with current plans to go back to the moon is how do we deal with this stuff? Unfortunately, all of the hard work done by these rovers was hugely overshadowed by the Apollo missions. Unfortunately, the Apollo missions were trying to create a moment of the first person on the moon. When that happened, everybody really kind of decided that the moon was boring. And so they didn't really care that the Soviets had sent some robots. Like in the wider public, they didn't care that the Soviets had managed to do the same things Apollo had done, but with robots. And they kind of got forgotten about by a lot of people, which is a shame, and why I like to talk about them a lot. There was going to be a Lunokhod 3. You in fact saw it earlier in that picture I took at the Science Museum. That's actually Lunokhod 3. It was going to fly on the moon, but they cut the funding and instead it became a museum piece and tours around the world being seen by people. But it was a huge success for the Soviets over on the moon, these missions anyway. And it's a shame that these have kind of been forgotten, because instead of being remembered for these incredible missions that they had on the moon, and their incredible missions at Venus, which I talk about more in the book, they were instead remembered for their failures at Mars. The Soviets really did not have a lot, still don't have a lot of luck over when it comes to landing on Mars. I think at the current tally, they have tried landing on Mars 18 times, and all of them have been either total failures or almost total failures. A couple of them did manage to land, but only lasted about 20 seconds on the surface. So really, Mars has gone on to become the purview of NASA. NASA has been the one exploring Mars. And the early missions that happened in the 1970s, there was the hugely successful Viking missions, but then people kind of fell out of love. Just as they fell out of love with the moon, they fell out of love with Mars. NASA was concentrating much more on human exploration in low Earth orbit for several decades. And it was only in the 1990s that people really began to take an interest in Mars again. And in the 1990s, NASA set up a group to investigate how they might possibly bring back some fragments of Mars to Earth. And what they came up with a group that discussed a Mars sample rover return mission. And this was a discussion group that went through all of the details about how would you actually send a rover to Mars and bring a sample back. And the answer was that they could work out how to do it. It would be a multi-phase mission. And most importantly, it would cost $10 billion. That is 1990s billion dollars, not today's dollars. So it was just way too much money for NASA at that time. They just weren't prepared to send it. And so instead, they started looking for cheaper ways to explore Mars. And that's when they came up with this guy. You might recognize this. This is the Pathfinder mission, originally known as the Mars Environmental Survey Pathfinder, or MESSA. And MESSA was originally going to be a station of 16 stations all over the surface of Mars. Each of them was a small, relatively low-cost mission, probably only a few $100 million, which for space is cheap. So if one of the stations failed, it was fine, but working together, they could create an entire global view of what Mars was like. But rather than jump in with all 16 feet first, they decided to send a Pathfinder mission to the surface to make sure it all worked. And as they were building Pathfinder, they realized that what they wanted to do was put an instrument on it called an APXS, which stands for an alpha proton X-ray spectrometer. Basically, this is a bit of kit that's on almost every kind of geological lander that can look at the surface. It shines a bunch of radiation, sees what bounces back, and it can tell you some of the elements that the surface is made up of. But if they just put it on Pathfinder and stuck it on a robot arm, it was really limited on what it would be able to see. However, there was a lot of room left in the lander, enough to put on a tiny little rover. And that's what you can see here on the front petal, the front solar panel. That is the rover that would go on to be called Sojourner. And if you shove the APXS onto this, it would be able to rove away, take a look at rocks and drive all over the place and get a much, much wider view of the landing area rather than just staying on the lander itself. Now, due to some funny shenanigans with funding at NASA, the rover was not technically classed as part of the Pathfinder mission. It was sort of its own tiny thing. Ideally, you would want to just treat the rover as another instrument on Pathfinder, but instead it was treated as a test technology for rovers. And that's its main goal was as a technology test bed. Any science that it happened to do came second. But it did teach us a lot more about, and it taught NASA a lot more about how to build some planetary rovers. Now, this obviously, Lunokhod massive thing, 1.5 meters high. This is about the size of a skateboard. You could quite easily lift it up. It's a much, much smaller thing. So there were some differences that they had to make when they were making the rover. Now, the first thing they did was change the wheel system. The one that was over on Lunokhod was a bit too complicated, so they came up with something called the rocker bogie system. And this is, you have the front 2 wheels on one side connected by a U-shaped bar, and then that bar is connected to the back bar. And this means that your rover's wheels can go up and down over uneven surface, and really kind of go with the lumps and the bumps and be fine and not risk rolling over. Secondly, because it was so much smaller, it had a much, much smaller solar panel. It was also much, much further away from Earth, which meant it couldn't communicate directly back with Earth. Instead, it needed to have a short-term antenna which communicated with a relay station, and then that relay station could then broadcast. That the relay station in this case was Pathfinder, and then Pathfinder with its big beefy solar panels could communicate everything directly back to Earth. Finally, it needed more advanced computers. In the 20 odd years of development since the Lunokhod rovers, microchips and computing had really, really exploded. And they could now put a little computer on it that would be able to store instructions and then be able to carry them out. It couldn't really start thinking for itself at this point, beyond sort of, oh, I think I'm about to fall over, I should stop now. But it was important that it could be uploaded with instructions that it would then follow through, because Mars is at best an 8-minute light round trip away from Earth. You cannot drive in real time with that. It would just take way, way, way too long. So instead, they had to be able to look at a picture of what Sojourner was. The people at NASA had to be able to look at a picture of what Sojourner could see, work out its route to where it wants to go, tell Sojourner, and then Sojourner would do it. And that was how that worked. And it was built and made its way over to the surface, eventually landing on the 4th of July, 1997. And unfortunately, at this point, they'd realized that the MESA mission wasn't going to happen. It was just Pathfinder on its own, a solo mission, but they were still going to try and get the most out of this mission that they could. But first, they had to land on the surface, and they did this with a combination of parachutes to take advantage of Mars's thin atmosphere, thrusters to kind of kill the last of the energy as it came towards the surface, but not quite enough. The landing was a bit too heavy to kind of bleed all of that velocity away. So instead, they wrapped it in bubble wrap. Same as you would do with any package you were delivering. In this case, it was a bunch of giant inflatable airbags that would expand out, and then when the petal, they would contract back in, could get wound in, and the petals could unfold. And here we see Pathfinder, Sojourner sitting on Pathfinder's petals. So essentially, this was another case of a rover landing on a platform. It just happened to be that the platform in this case was Pathfinder, which was itself a science station. And here it is sitting on the surface. By the way, don't worry if the image looks a bit weird. It is a 3D image that is supposed to be viewed with those red and blue 3D specs. But it's the only picture I can find. And as you can see at the front, you might be able to work out that there's these kind of like 2 cylinders at the front and back. Those are actually the ramps, but they're all spooled up. And then eventually they got unspooled and Sojourner made its way onto the surface. Here you can see it on the surface, looking absolutely fine. This was the area around it where it explored. It was part of it was very imaginatively called the Rock Garden, but all of the rocks within the area had much more imaginative names. Things like Yogi, Zaphod, Indiana Jones, All of these named after various different pop culture references. There's actually a couple of mountains in the background which were named the Two Peaks after a popular TV show at the time. Just proving that all NASA is run by a bunch of giant nerds, as I am sure will surprise no one. But what they saw of this area is that all of these rocks were very much a mixed bag. They didn't all seem to come from the same origin. They didn't all seem to have started their lives in the place where Sojourner found them. Something appears to have brought them in. And in fact, it looks like what has happened is that there was a giant flood in Mars's past, and all of these rocks got carried and swept across the area and littered around on the surface around where Sojourner eventually ended up. And this was the beginning of one of the big questions around Mars, which was there water on Mars, large amounts of water on the surface in Mars's past? And that is all one of the big questions that surrounds Mars. People, by this point in 1997, people had really started liking Mars again. It'd gone through a kind of rough patch, but now the public was very, very enthusiastic about Mars. There's potential that there might have been water on Mars. There was potential that there might have been life. And there was also something you might remember a couple of years ago, something called the Allen Hills meteorite, which contained potential fossil bacteria that turned out to not be that at all, but it got people talking about Mars again. And so NASA came up with something called their decadal plan. And this was a plan to send a mission to Mars every single launch window. So every 22 months when 26 months when the two planets were close to each other, they'd send a mission starting in 2003. Why 2003? Well, it's because this was the time when the two planets would be even closer together. It was their point of closest approach. And so basically that meant because a rocket wouldn't have to go as far, you could get more bang for your buck out of your rocket. You could lift a much bigger mass. So you could send something nice, big and heavy. And what they decided to send was another rover, but much, much bigger this time. And rather than sending one, they were going to send two, because the chances of one rover failing might be pretty high, but the chances of both failing is much, much lower. So what were these rovers? These rovers were called the Mars Exploration Rovers, or MER, and they had four basic goals in mind. They were going to characterize the planet's past and present climate. They were going to examine its geology, find out if it could have had life in its past, and pave the way for human exploration. That last one, paving the way for human exploration, was kind of vague and wishy-washy. It was basically going to say, can we land something heavy on Mars? As they would have to do if humans went. And what kind of things are there on Mars that humans might be able to use if they went there? But it was the first three that the rover really hammered into. The Mars Exploration Rovers were basically mobile geologists that were going to go around the surface and explore what the surface of Mars was really like. And this was the eventual design they came up with. You might see it kind of looks at, if you take the top off, it looks very similar to Sojourner, because that's basically what it was. It was basically a beefed up version of the Sojourner rover, but with a much, much bigger solar panel plonked on the top. In fact, you can see it there. It's kind of got these really kind of dramatic winglets, they're called, coming off the back, which were partly because it meant they could get more solar panel area, which is always good, but also because they just looked cool, apparently. It's one of the main reasons why people really like them. It also had more instruments. It had the APXS again, but it also had it had microscopes, spectrometers, and much, much better cameras. It also had something called a rock abrasion tool, or a RAT, which would rub away at the planet's rock surface to exposed the pristine rocks beneath. So you could really, like, you didn't want to look at the bit that'd been sort of like sitting in the sunshine for a billion years. You wanted to look at what the rocks were really like underneath. And here are the two rovers being built. Now, by this point, you might know these two guys better as Spirit and Opportunity. They did go by a bunch of different names, but that's very confusing, so I just call them Spirit and Opportunity. I believe that is Spirit at the front and Opportunity at the back. Now, these two had a very troubled upbringing. They had a lot of problems throughout their entirety of their development. Spirit kept misbehaving, kept refusing to shut down when people were running tests on it, to the point that somebody wrote a code that was literally called "shut down, damn it," to shut it down. There was a test that they tried to do. They realized right at the last minute that there was a fundamental problem deep inside the rovers, and they had to blow open all of the pyros that were keeping them struck down, which caused a whole bunch of problems. When Opportunity tried to fly, the cork layer on the outside of a rocket, because apparently there's a cork layer on the outsides of rockets, I didn't know that before I started writing this book, was peeling off because it had been raining too hard, and they just had problem after problem. But they did eventually make it to the launch pad on time in 2003, managing to make that short window, and they made it to the surface of Mars. And here we see Spirit looking out over its plain of rocks and dust. The rovers were designed to last for 90 sols. Sojourner, I forgot to mention, only was supposed to last 7. It actually managed 84 sols before a problem with Pathfinder took it out of the running. But these, their kind of red line, first degree time limit was 90 sols, or 90 Martian days. And the thing that they thought was limiting on how long these rovers would last wasn't their batteries or their wheels, or how long they thought the mechanisms could last. It was actually the dust. Because as you can probably see in this picture, those solar panels get very, very dusty. Mars has a very thin atmosphere, but it's enough to cause gusts and winds that were constantly blowing dust onto the solar panels. And they'd seen this with Sojourner. Over its 84 sols, the solar panels getting dustier and dustier, and the power levels dropped off. And if this carried on Mars for the Sojourner, for the Spirit and Opportunity, eventually they would just get too dusty, the solar panels couldn't see the sun, and they wouldn't work anymore. They knew that was going to happen. They hoped they could get a bit longer, like maybe a year out of them, but they were just going to see how long they went. We were expecting it to last a year, maybe 2, before they were too dusty to work. And then, after they'd been on the surface of Mars for a couple of months, something very interesting happened. One day, Spirit woke up and reported that its power levels had jumped up by 5%, which was very unexpected. And so the NASA engineers got it to take a little photo of itself, and they realized that its just solar panels had cleared miraculously overnight. Some kind of weather event. I think they're still, they think it was possibly a dust devil. It might have been something else. Cleared off all of the dust, and suddenly Spirit was good to go again. Same thing happened to Opportunity not long after, and every couple of months, these dusts got completely cleared off of these. Suddenly, they went from having a mission they thought might last at most 2 years, could last indefinitely. It could last until these things fell apart. And it did. So Spirit landed first on the moon, on the Mars, on the 4th of January 2004. It landed in an area called the Gusev crater, which was believed to be the bottom of a former ocean. There was evidence of hydrothermal activity, so hot water
bubbling up from inside. And those were the kinds of places, hydrothermal vents on Earth, where people think that life might have started on Earth. So there was a lot of interest there of potentially this might have been where Mars also might have had life. It lasted for 6 years on the surface of Mars, traveled to 7.73 kilometers, which is a lot further than Sojourner traveled. Sojourner traveled about 100 meters, so considerably further. Unfortunately, it in 2008, 2009, its wheel got stuck in a sand pit, and it couldn't move anymore. They tried getting it out, but they couldn't. NASA couldn't do it. So they changed it to a static station, which was fine until the winter weather rolled around. And it just got too cold in the winter, and it never woke up again. And they ceased trying to communicate it on the 22nd of March, 2010. Opportunity lasted quite a bit longer. It lasted 14 years on the surface. It landed in a place called Meridani Planum. And this was a really interesting site. It was unlike anything that NASA engineers had ever seen before on the surface of Mars. Everywhere else had been like rocks thrown all over the place, and they just assumed that's what all the Mars was like. But the first pictures from Opportunity showed these incredible sand dunes stretching out into the distance. And in fact, this is one of my favorite, pictures of all time, let alone from space, of just Opportunity looking back at its tracks over this incredible flat, dusty plain. But I digress. It traveled a total of 45 kilometers. It went really, really far. And in fact, this was its massive journey. As you can see, it started off over here, went past all these craters and did all of these things. In fact, they had a bit of a trouble, like the opposite problem to what they had with Lunokhod, where they couldn't stop to do science, which was in the early days, they kept stopping to do science. And they kept like looking at every single individual rock that was around them. And eventually the people in charge of the Spirit and Opportunity had to say, look, we could spend our entire mission in this crater and it would be very interesting, but we could also go over to that crater and find something absolutely astounding. And so they had to set limits of like, okay, you need to be over by that crater on this date, and it's up to you how many things you stop on the way, but you need to be there by that date. And there was a lot of again, this constant tension between, trying to get somewhere interesting and actually looking at the things you're there to see. Now, unfortunately, Opportunity, you might remember back in 2018, there was a global dust storm that encompassed the entirety of Mars. And unfortunately, the thickest part of that dust storm was right over Opportunity's head. It couldn't charge its solar panels during that time. And though NASA tried and tried and tried to get back in contact after the storm, it never got back in contact. We don't know whether it was a problem, with the dust taking out the communications, or whether it's just buried in a pile of sand somewhere. But it had an incredible, incredible time on the surface. In fact, it had, between the two of them, they had 20 combined years, Earth years, not Mars years, on the surface. I can't really, that's, an entire, let alone an entire talk by itself. You could have entire conferences about what these two discovered. But the main thing that they taught us was how to operate long-haul missions on the surface of Mars, that it was possible to operate these long-term missions on the surface of another planet. The other really important thing they taught us was that there was water on Mars. There was definitely water on Mars. Speaking of, excuse me. And now there is water in me. What these two rovers found was that they found various minerals and things like clays and carbonates. All of these find geological features that can only form in the presence of water. Spirit found that this water was probably going to be acidic, whilst Opportunity found that the water was actually more neutral, more like something that you would find on Earth. And that was really interesting, because that meant if there was water in the past on the surface of Mars, and that water has changed over time. It was at some point potentially habitable, but then something happened to the climate that made it potentially acidic. And so that got people thinking, well, we know that the water was around. What else was around that could have possibly been an ingredient of life that possibly could have led to life existing on the surface? And to look for organics, you need, or that's what you call organics, which means material that is the building blocks of life rather than something that is made by life. That's an important distinction. So they were looking for these organics, but those organics are very hard to find. Something like the APXS just won't pick them up. You need something like a big oven, and a big oven required big rover, and that's why they came up with Curiosity. You can see Curiosity over here on the right. So that's a Sojourner down at the bottom on the left with an MER net above it, and then Curiosity on the other side. As you can see, they are just completely different sizes to each other. Curiosity was a big one. And it had on it something called the SAM, which was the Sample Analysis at Mars, which was basically a big, beefy oven that it could shovel rock samples into. They get superheated, and then they could measure what gases came off of it and work out what was inside of those rocks, what kinds of things were made up from them. In order to do that, because big powerful ovens need a lot of battery, they need a lot of power, and a solar panel just wasn't going to cut it. So instead it had something called an RTG, or a radiothermal generator, which is basically like a big lump of radioactive material that's basically a hot brick that you put something called a thermocouple on that can convert that heat directly into electricity. And that is a lot more efficient than solar panels, but it's very heavy, it's very expensive, and incredibly hard to install. I think it's something like your maximum lifetime exposure to an RTG when you're putting them in a rover is something like 30 seconds. So they had to kind of put it in, have someone do a bunch of work on it, then swap it out for somebody else who would finish that bit up. And it was an incredibly difficult thing, which is why they tried to avoid using them. But it also meant it was far too heavy to land in the ways that the other two had. So Spirit and Opportunity had landed in basically a carbon copy of the same things Sojourner had, except instead of Pathfinder, it was just a box. But they still had the same airbags. Curiosity would have been too big. It would have just burst those airbags outright. So instead, they had to come up with a bit of a crazy plan. They created something called the Sky Crane to land the rover on its wheels, which, when they suggested it to the NASA administrator at the time, is reported to have said, yes, it's crazy, but it's the right kind of crazy. Let's do it. And it was basically a platform with a bunch of thrusters on. The rover hung underneath it, and then the platform would slowly bring it to the surface and then detach it and go away and crash somewhere else. And this allowed for a much higher precision landing. As well as a much bigger weight, it was a much more precision landing. That's important if we ever want to send humans to Mars. That's probably going to take several different missions. And so you want to be able to land all of the bits of those missions in the same place. So being able to, kind of land something in a much narrow field of view is much better. It also meant they could land much closer to the interesting thing that they wanted to go and see. So this is where Curiosity was going, Gale Crater. And Gale Crater is interesting because it's a big crater that they think was once filled with a lake, but importantly, it had a big mountain in the middle called Mount Sharp. And so Curiosity could land in that blue circle. In fact, it landed right on that green dot. And then get really close to the thing, because they knew that there was a high precision of where they could land. They weren't going to risk landing on the mountain rather than next to the mountain. And then it didn't have nearly as far to go up the mountain. But why do you want to go up the mountain? Because the mountain has lots of layers. Mount Sharp has a whole bunch of different regions, but different layers. And each one of these layers was laid down at a different time in Mars's past. So as the rover drives up the mountain, it drives through these layers, can take a look at them, and really get to understand how Mars changed throughout its history, how its climate has changed and evolved. And Curiosity landed back in 2012. It is still going strong, and it has taught us a lot in that time. One of the main things that we found was that it's found these organics that it went to go and find. So these building blocks of life, it found them on Mars. But the other thing it seems to hint at, along with some other missions that have been looking at Mars, is that the history of water might be a bit more complicated than people first anticipated. So rather than there being in the past a nice wet Mars covered with these huge oceans of water, it might have instead been that Mars was only occasionally wet, that a meteor strike melted a bunch of ice that created a flash flood across the surface. And these are two very different things, and people are still kind of trying to work out which one of these might have been the case, and there's lots of different evidence for both of them. But it was an interesting start, and really getting to grips with what is going on with Mars's past history, its past water, and its past evolution. But the one thing it can't do, and it was never going to be able to do, was give a definitive answer of whether or not there was life on Mars in the past. That wasn't their intention. It was more to assess what was there and whether Mars was habitable, not whether it was inhabited. For that, you need a much more complicated mission. You really need to be able to take a piece of Mars and look at it with the best equipment that we have on Earth. And you cannot take these enormous instruments and huge labs that we have on Earth to Mars. It just won't happen. Instead, it's much better to bring a bit of Mars back to the labs. And so that's when people started returning back to those ideas that we had in the 1990s and sending a Mars sample rover mission to the surface. And this is the current plan being done by NASA and ESA. Now, what this is a slightly complicated diagram, but basically what it shows is 3 stages of the mission. The first one is Mars 2020, which is now better known as the Perseverance rover, which is currently sitting on the surface of Mars. And this is a big rover that will go around, find the most geologically interesting places across Mars, scoop up some rocks, and put them into test tubes that it will then leave in caches. That a second mission, which is currently, I believe, being planned by both the European Space Agency and NASA, that will send a much smaller retrieval rover that will go pick up these caches, take them to some kind of launcher that will launch them into orbit, where a third mission will come along, scoop them up, and return them to Earth. So 3 separate missions, all to bring a bunch of rocks back to Earth. It's quite complicated, and you can see why it's taken us a little while to get there. But we are getting there. And in fact, we have built the Perseverance rover to do just that. Here it is. Good old Percy. And it's very similar in size and shape to Curiosity. However, it's been updated by a decade of improved electronics and technology. So it does all of the things Curiosity could do, but better, and is in fact an even more advanced geologist and has a couple of extra instruments on there as well. But its main goal isn't to explore the surface of Mars itself. Its main goal is to return those samples back to Earth. And of course, Perseverance landed on the 18th of February this year. This year? Yes, this year. And is currently sitting on the surface. It is still going through its checks and making sure that everything is okay. This is the view of the Perseverance rover from the sky crane. And did I put this on here? Yes. Hopefully this will work. It was the first. And here you go. So it was the first rover to actually have cameras mounted on the rover itself. And there it is, shooting off into the distance. And then how do I change the slide? Now, hang on. There we go. So that was Mars landing on the surface. However, it didn't travel to the surface of Mars by itself. It had a little friend along for the way called the Ingenuity helicopter. The Ingenuity helicopter Mars Scout, I think, is its full name. And this is kind of the evolution of these mobile explorers going across the surface of Mars. Because Perseverance is an incredible machine. It will be able to go huge distances if it needs to. It can get to some really interesting places. However, it is on wheels. There's only so it can't go to the most craggy places. If it gets to a cliff, it can't just drop off the cliff and get to the bottom. It has to find a way down or just go alongside it. If there's a big mountain in the way, it's got to go around. So instead, what NASA are looking at is other ways that you can explore the Martian surface. And that's using things like Ingenuity. Ingenuity, by the way, is about the size of a tissue box, is what they usually say. It's only about 2 kilograms in weight, in mass. It's quite a small thing, but it was a test demonstration to see if you could fly a rotorcraft, as they're called, so basically mini helicopter on the surface of Mars. And as we found out a couple of days ago, yes, they can. I've had to do some updates in the last couple of days to this talk. And it's, in fact, I think, yes, so it managed to make this its first successful flight. The first ones, again, is just a tech demonstration, so it went up by about 5 meters and then flew side to side and then came back down. Because it's just a demonstration, it's only got a camera on board. It doesn't have any fancy instrumentation, but the cameras did do work. They managed to give these incredible vistas. And in fact, one of them the shots actually managed to get Perseverance over there in the corner. And the idea behind these is that you could one day use these to get to areas and to places where a rover can't go. If it'd be too difficult, too dangerous, you could send one of these craft. And it's also a move towards maybe saying these huge, big, and incredibly expensive rovers aren't the way forward. maybe there is a way to still explore these worlds, but with something that's much smaller and maybe a bit cheaper. And of course, we're already seeing this sort of thing happen, this sort of maneuver happen over on the moon with the Chinese rovers. There's the U2 rover, which landed back in 2013 and explored the surface. Unfortunately, after its first lunar night, it broke and couldn't move anywhere. And then the Chinese sent the U2-2 rover. Have to be careful how you say that one. U2-2 to the far side of the moon. And this was the first time anyone had landed on the far side of the moon. And it was done by the Chinese. And they had this tiny little rover. Unfortunately, there was a bunch of geological instruments on the first one, but they got taken off the second one to make sure that it didn't break and it could still rove around the surface after the first lunar night. So unfortunately, they sent something to the far side of the moon and then tied their hands behind their back so it couldn't actually do any really, really interesting science whilst it was there, which was a bit distressing for a lot of geologists. But unfortunately, it's better to have a rover that rows and can look around, but can't, even if it means it can't fully look what was there. And currently in orbit around Mars, there is another one of these small rovers, the Tianwen-1. I'm not 100% sure when China are planning on landing that one. I think it's sometime in the next few months. That will be landing on the surface of Mars. So there will be 2 rovers on the surface of Mars in a few months, and a helicopter. Oh, that's not supposed to be there. Of course, China's not the only people who are landing on Mars. There's lots of people who have been trying. The Indian Space Agency tried back in 2019. Unfortunately, that rover, their Pragyan rover, crashed as it was coming into the surface. They are planning on reattempting that one. And as you can see from this picture, it's a very, very similar to Sojourner. People sort of like, they don't tend to go that far with rover designs when it comes to the big space agencies. Instead, they leave that to the private companies to come up with all sorts of weird and wonderful things. A couple of years ago, there was a project called the Google Lunar X Prize, which challenged lots of people all over the world to build a rover that was capable of going to the moon, landing, driving 500 meters and returning photographs, I think was all of the recommendations. And unfortunately, that went without anybody winning it. But lots of people carried on building their rovers after this fact. Some of them were from scientific institutes and universities, like the one on the top left, which is from Carnegie Mellon. And that was very much just a kind of like bog standard rover, but trying to make it as cheaply as possible. Some other people, like the UK company Spacebit, tried something a little bit more interesting and came up with this kind of weird robotic spider design to go scuttering across the surface of the moon. And then at the bottom, you've got the Netherlands Pulis Space Company, the Hungarian, Pulis Space Company, who built this weird thing with weird legs that would, again, that's all to deal with the lunar regolith, so it can kind of go across the surface rather than going on regular wheels. So there's all kinds of different people now trying to get out there and exploring the surface of Mars, the moon. And it's not just the moon that people are exploring. There's lots of people. NASA is now turning its attention towards the icy moons of Jupiter and Saturn. There is already plans to send another aerial scout called the Dragonfly to the moon of Saturn's moon Titan, which has a thick atmosphere, one atmosphere of very Earth-like, but much, 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 much colder. There's other plans to somehow drill down through the ice of the icy moons and explore the oceans below. And both of these are considered to be like our best place where we think is most likely that life might have evolved. So it's a very exciting time when it comes to planetary exploration. There's a lot going on. Things are constantly changing. Literally every time I give this talk, I have to update the Perseverance Ingenuity bit. So it's a very interesting time, and I'm thrilled to be here, seeing what's going to happen next. But that is only the story of rovers. There are lots. Rovers are only part of our planetary exploration story. There are a lot of other kinds of landers and other robots that have been and explored these planetary worlds. And if you'd like to hear more about those, I talk about them in my book, Robots in Space. And with that plug done, I'm more than happy to take any of your questions, and thank you very much for listening.
Well, thanks very much for that, Ezzy. Very, very interesting indeed to see the wide range of rovers that are out there. So do we have any questions? I don't see any on chat. No. So I've got
a very bad one.
Yeah, I've got a question actually. Do you think that particularly with the success of something like Perseverance, that it will really draw a line under human exploration for Mars and make them think twice about doing it? Or do you think they'll still go ahead and maybe have an attempt at human habitation just for a while to see if it's possible, and then maybe can it?
Human exploration is a bit of a weird one, because generally speaking, robotic exploration has been about doing science and looking at the surface science. Human exploration is not motivated by that. The Apollo mission, one of the things that was like, if you go into like the original documents behind it, it was always very clear that this is not a scientific mission. This is a mission to go and explore and push the like boundaries of where humans can go. So in terms of sending humans to the surface of Mars to do scientific missions, I think it will happen, but not because it's the most sensible thing to do scientifically. It will happen because of political reasons, or because people want to go to Mars. And it might be by that point, you know, Elon Musk has got his dreams and he's worked out how to get people to Mars, and it's just NASA buys some tickets with him. Or like whatever space agency wants to go. But I think there is too much invested in human exploration of these planets for it not to happen, even if robots were technically the best thing to do the science.
Okay, good, thank you. There's a question actually in from someone that says, why are six wheels popular? I'm not so sure that you can answer that one, but it seems to be
I think it's just that NASA came up with the rocket boogie system, and that works very well with six. If you add on another wheel, it kind of gets a bit, trips over itself. Not all of them are. Some of the weird and wonderful ones have 4. Some of them have 8. Some of them don't have any wheels at all. It just happens to be that NASA basically, when they pick a design and they like a design, they don't change it.
Yeah.
And they've picked the rocket boogie, they like it, they're not going to change it, and a lot of people have been copying them. Is basically why Space 6.
Yes, good, thank you. There's a couple of more questions that have come in since we've been talking, and question again, what is the next interesting thing to expect from Perseverance?
So Ingenuity is going to do a couple more things. It's going to attempt to do some science, which will probably just be photography. Exactly what that's going to be, NASA is being a bit vague on. They literally just announced before I came on here that it's done its demonstration thing. We're going to try and do something a bit more interesting now. So unfortunately, I can't tell you much about that. But over the next couple of months, Perseverance itself is going to prepare to get going, basically.
Sure.
So it's been on there since February.
It's been, you know, checking out its systems, making sure everything's working fine. It's run the Ingenuity experiment. It's run another experiment called MOXIE, which was it took in carbon dioxide from the atmosphere, broke it apart, and got oxygen, which is very useful if you're trying to explore space. And so now it'll just prepare to kind of go about its business.
Good. And there's another question here from Stephen King. Are there any planned missions to the Mars polar regions looking for water? Same for the Moon?
There has been a couple. There has been a mission to the Mars polar region, which was Phoenix. Yes, Phoenix. The problem is it's very difficult, especially if you're trying to send a rover, because it does get very cold. So there aren't any plans to kind of go back there anytime soon from NASA. I would not be surprised if China does, as China steps up its decisions around the Moon. China steps up its game around Mars. However, China are not terribly open about what they're doing or why they're doing it or when they're doing it. So yeah, in the next couple of years, I wouldn't be surprised to see that happening.
Okay, good. There's a question here from Stephen Moreland. In view of the dusty atmosphere on Mars, how do they keep the cameras clean?
Oh, that is a good question. I know when they're landing, they've got lens covers on, which is usually why, like, whenever you see the very first picture taken from a rover or whatever, it's always like in a circle and looks really rubbish. It's because it's through a lens cap. I think generally it's just, you know, they are sort of angled in ways where the dust isn't going to hit against them as much. It's more a problem of dust settling on them from the top than kind of wind bombarding them. The wind's very, very light, so you don't have to kind of like worry about them getting sandblasted or anything. So I don't think that's a huge issue.
Right, another question here you might be able to answer. It's from Andrew, and he says, after Mars and Titan, are there any other planets under consideration for exploration by rovers?
By rovers? Oh. Probably not. There's plans to sort of go to one of the icy moons, but that's more likely to be because the conditions there are so cold.
Right.
It's going to have trouble roving around the surface. There are plans to go back to Venus, but it's very hard to build a rover that can survive, you know, hot enough temperatures to melt lead at 92 atmospheres. There's some ideas like involving clockworks and things, but yeah, so that's unlikely to happen. But I think currently there aren't any plans to go any. There's people who've like come up with crazy ideas, but no actual kind of like cast iron plans.
Right, great. Okay, well, I think that probably is all the questions. So thanks ever so much for that.
There's a couple of people with hands up, sorry.
Yeah, all right, okay. I'll tell you what.
I can just see them waving.
Let's come back and we'll take this back. Yeah.
Okay.
Yeah. Let me just get rid of that for a second. Yeah, stop sharing that, and we'll go back to here. Okay. So yeah, anyway, go ahead, please.
I got a question. Looking at the particularly the Russian rovers, the cameras seem to be fixed in the bodywork, just pointing in one specific direction. I'd have thought they would have been able to rotate them so they can have a look around without moving the rover around.
Yeah, at that stage, it was a question of having the least number of points of failure, basically. And at that point, when they were building something, they needed to have everything encased in that big, heavy metal container, which meant there wasn't a lot of scope to move about. Also, anytime you say moving joint to someone who has to build anything on a spacecraft, they will cringe. Because the more places you have on a spacecraft that move, the more things you have to go wrong. And so they avoid them as much as possible. So it wasn't ideal, but given the kind of like time and they had available and the technology they had available, it was just keep them straight, make sure they work. If it means we have to have a slightly awkward drive, then we had a slightly awkward drive.
Okay, well, thank you.
Any other questions?
Yeah, can I just come in and it's actually an observation. You were talking about the Spirit and Opportunity land rovers. I read some years ago a very good book by Steve Squires, who was mission sort of guy on these particular craft, and the book was called Exploring Mars, and it really does. It's quite actually frustrating to read, because you go through the entire development of everything and the business with the cork on the launch of I think it was Opportunity and everything else.
Yeah.
It just does conjure up the amount of work that needs going into these things. And there's a little poignant thing about that, because when it was built, it was just after 9/11. There are apparently I think it's the rats have got covers that are actually made from part of one of the steel girders, or one of the steel plates from one of the buildings, and they have a stars and stripes on them to commemorate that event.
I do have to say that the chapters about Spirit and Opportunity, because I had to split it over two because there was so much to talk about. A lot of them were taken from that book. It's Roving Mars by Steve Squires.
That's it. Yeah.
Which, if you are going to read any book about rovers, apart from mine, obviously, I really recommend that one, because it is a brilliant book, and there was just so many things in it, and it was so annoying that I couldn't put more things in.
Yeah.
But yes.
Thank you.
Great. Well, if there are no more questions, then we shall move on to Richard doing the planetarium presentation. But I would like to thank Izzy once more for a very interesting talk. Thank you.
All right. Thank you for having me.
Yeah. You're welcome to stay on if you wish, or if you need to disappear, we understand as well. Thank you.
Unfortunately, I haven't had dinner yet, so
Goodness.
I'm going to go do that.
You're definitely excused then. Thank you very much again. So, Richard, let's see if we can get you to be host again.
Yeah. Okay.
Host, there you go. You should be able to share your screen now, hopefully.
Yeah. And there we have it.
Okay, we're not. Yeah, sit. Right.
I'm just going up to full screen, and then we have the full screen. Hopefully, can everyone see that?
Yep.
Good.
Yeah, I can see it fine.
That's a relief. That's a relief. Now, what we're looking at the moment is the sky at this moment. But if you went outside, you'd actually see that, or you'd see something like that anyway, not quite as good as that. What I'm going to do, I'm going to advance it a little bit, because we want to move on a little bit, because we're going into May, and we need to be a bit further forward. So we've moved on. Now I'm just getting my bearings. So that's Virgo. This is Spica, and this is a little constellation of Corvus down here. That's an interesting constellation. It's actually the Crow. Crow is sitting on the back of Hydra. This is Hydra under here. Hydra very, very low in the sky. The reason the Crow is sitting on the back of the water snake is a bit strange, really. We're not entirely sure why, but he's trying to drink out of a cup called Crater, which is here. And there's a story about Apollo here that he sent a crow to get him some grapes, and he noticed when he got back the crow had a drink on the way back, and he was very cross with him, so he put him in the sky. So that's why we have a crow. Amazing, these things, aren't they? I constantly wonder about Greek mythology, but we'll come back to that in a few moments. So I want to move on a little bit further still, and we come to what we might call summer sky. Now I'm going to put some labels on here just so we get some idea of what we're talking about here. So this is what you might call the summer sky, the early summer sky. And what I want to talk about particularly is this area here, which is Hercules and Corona Borealis. Now, I'm just going to take these off so we don't get confused too much. Names off. Corona Borealis commemorates the crown. It's called the Northern Crown. That actually comes from. Do you remember Theseus and the Minotaur? The story about this young lad that goes over and goes into the labyrinth and slays the Minotaur, and he's helped by a young lady called Ariadne, who madly falls in love with him, and of course they run off together after the event. Theseus makes two classic mistakes. One is that he forgets when he's going back to Athens to take down the sails that are black. His father then thinks that he's been killed on the mission, because that's what he'd say. I'll leave the flags up, we're going to have the black flag sails. So his father killed himself, which is why the Aegean Sea is called the Aegean, because that's Aegeus was his name. The earlier story is that Ariadne, when he gets to an island of Naxos on the way back, he decides he doesn't really want Ariadne anymore, and he leaves her, which is a really unfair thing to do. Then the god Dionysus turns up, and he rather likes Ariadne, and he says, well, don't worry about him, I'll marry you, we have a good time together with a few drinks. So he throws a crown into the sky, and this is what it is. So this is the crown that Ariadne would have had. So that's another weird story from Greek mythology. So there we go. So let's put some lines up just for a few minutes, so that we've got some lines to locate things. So here we've got Northern Crown of Corona Borealis, and that bright star there is called Alphecca, which is about second magnitude. And here we have our old friend Hercules. Now, the main feature of this constellation, I have to say, it's not particularly bright. It looks much easier to see in a planetarium than it does in our sky at the moment. This is the main feature, this area here, which is called Keystone, for fairly obvious reasons. Now, it might seem strange to believe, but the constellation of Hercules is actually upside down. He's standing on his head. Just to give you some idea, I'm going to put the lines up on here, the constellation figures, and there you can see what I mean. He's actually up here somewhere. He's actually up here, upside down. So his head is facing Orpheus down here. So you've got a man who's standing on his head for a start, which does seem a bit odd, but there we are. Turn those off. So the Keystone. Well, this is a really famous part of the sky, because that is an asterism, by the way, another one like the Plough, etc., that I've talked about before, because located right here is a very famous globular cluster M13. It wasn't discovered, although we call it M13, it wasn't discovered by Messier at all. In fact, the first person to really draw attention to it was Edmund Halley in the preceding century. He noted that it was a little patch of light in Hercules that was, when the moon was absent and the sky was clear, could be seen, which it can. So that particular cluster is about 25,000 light years distant. That's quite a long way away, but it's a target for telescopes. It really is. Whatever you've got, have a look at it. You've got binoculars or a telescope, no matter what size, you always see something in it. And it's a really interesting object, and also interesting from the point of view of photography as well, or imaging, I should say. That's not the only globular cluster in Hercules, because located on this line here, this line here, the star here is Iota Hercules. Located about here is another globular cluster called M92. Now that is one of Messier's discoveries. It's a bit more distant than the famous M13. Nonetheless, it's a really interesting object, and when you compare them, if you can get your telescope and look at that one, and then look at that one and go back again, you can see they're actually quite different. This is even noticeable in binoculars, believe it or not. I know because I've done it. The centre is more condensed and on the M92 than it is on M13. So there are differences in globular clusters, and that is because some of them are actually losing members. They're actually because of various tidal influences going on within the cluster itself. Because don't forget, you've got all these stars. They're not crammed in, but they are gravitationally interacting. And occasionally a slingshot maneuver will throw some stars out. And sometimes that happens. And when that happens, the cluster starts to lose members. And M92 is one that is very, very slowly. Also, this star here, this is his head, remember? This star here, which is Alpha Herculis, it's an orange star and it's roughly 400 light years distant from us, but it's an interesting star because it's actually double. It's rather nice, colourful double star. And if you look in most books, it'll say that there's a green companion to that star, and that's because the star is orange. The main star is orange. The other two stars, spectroscopically, they actually show up as similar spectrum to the sun. So they're not green at all. In fact, there aren't any green stars. So that's interesting because it's a matter of physiology of the eye and a number of things that cause that to look green. And in fact, it's even more complicated than that because spectroscopically, those two, one star is actually two. Of course, no telescope on Earth will show them. That's why they don't show up on the spectroscope as a twinning of the lines, which proves that there are two elements in the system. This whole business of colour and stars, there's other stars that are problematic for colour. For instance, this one here, which is 95 for Herculis. When it was first looked at with telescopes, people said that it was definitely cherry red and apple green. Well, it doesn't look that way to me or to most people, but what it does indicate is that people's eyes are different. And last year in the Society, the History of Astronomy, the magazine, there was an article on this very subject and why these physiological differences do change and why some people see different colours. And it's to do with colour blindness in some cases, and in other cases, apparently colour is different between women and men, and that can make a difference. Women can see greens much better and yellows, whereas men tend to see things slightly more black and white. So that might indicate why there's a difference. But what I'm saying is that it really is a beautiful subject. Do have a look at coloured double stars. They really are fascinating. And it's like going to a jeweller's shop. You don't have to buy, you can just have a look on your own because they're beautiful gems. And of course, I couldn't really finish this bit without talking about Lyra. Lyra is this constellation here. It's the primary star, Alpha star, is actually bigger, which is going to be overhead in the summer months. At the moment, it's rising in the east and in the late evening. And it's noted by this as what somebody called its dog tag of these four stars making up a parallelogram. It's a very interesting constellation. Although it's very small, only if you've got this beautiful blue-white A-type star, 27 light years distant, making a really brilliant zero magnitude star here. Also, you've got an easy double here, which you can see with the unaided eye, actually, almost, which also through a telescope reveals each of them is double. And you also got a star here, which is Beta, and that is actually an easy to see double star in a cluster of stars. that surround it, and one of the stars is bluish and the other is slightly orange. And of course, down here we have one object that has been photographed and particularly by images in so many different ways. It's called the Ring Nebula. It's M57 on Messier's list, although he didn't discover it. It was a guy called Arquia who'd actually discovered it some years earlier than Messier, which is, can't see in binoculars. It's too small and it's a bit dim. It's about 9th magnitude. Under most conditions of light pollution, a telescope will show it quite easily, and it's located on this line here. You really can't miss it. It looks like a tiny smoke ring on the sky. And this is the one that people have given lots of different names to, bearing in mind which different types of filter system they use on their imaging system. But it's a fascinating object, and it's an example of a planetary nebula, and that has nothing to do whatever with planets or even to some extent a nebula. This is gas that's being blown off by a star after going through the giant phase, and it's actually being lit by the ultraviolet radiation going off from the star, actually fluorescing the material, and that's why it looks somewhat like a ring or odd shapes like circles or whatever, or discs. That is the actual dust, the actual gas cloud spreading out through space. So there's plenty to look at in the summer sky at the moment. This is the spring sky, and you've got to remember too, as we head towards June, the sky itself is going to be much lighter, even with light pollution. We still have a problem with sky brightness of the actual evening being lighter, and it doesn't really get dark at all in June. We have a sort of perpetual twilight. So these things do tend to cut through light pollution and these twilight nights quite well, particularly doubles. So it's well worth having a look at some of these objects, and just bear in mind that shortly coming up we will be having the planets Jupiter and Saturn. They will be merging into the summer sky later on in August, etc., when they will be in Capricornus in the case of Saturn and Jupiter. And of course, at the moment in the evening sky we have Mercury and Venus. Very low down though. By October, Venus will be high in the sky in the evening and really quite brilliant. So we've got that to look forward to as another object to look at. Although I must admit, telescopically, it's a bit of a disappointment. There we are. So that's a brief look at the sky for next few weeks. Of course, the other constellations are still to view, and just one thing I would point out about Leo, which is sneaking off here to the west, is that he is responsible for the death of not only Hydra. We're talking about the snake, the water snake down here that's disappearing, which had 6 heads apparently, and every time you cut one off, it grew again. He also got rid of Leo, the Linnaean lion, and he also got rid of Cancer the crab. While he was fighting Hydra, Hera, which was Jupiter's wife, who didn't like Hercules at all, sent a crab to annoy him while he was fighting with the Hydra. So he trod on it. So that's. I must admit, I'm endlessly untrammeled with a classical education. I really do like Greek myths. They really are pretty fantastic, and you can understand them. Whereas Egyptian mythology, I'm afraid, completely escapes me because it's kind of dream worlds. It's a kind of odd thing where you can actually see the gods really have tempers and everything else with the Greeks. You don't have a problem. They could make a very good version of EastEnders, I think. Anyway, I hope that helps, and enjoy the rest of the month.
Great. Thanks very much, Richard, for that. And glad to see everything went well this time. You've really cracked it there. Thanks for that.
Yeah, we have. Yeah, and thanks to Graham as well.
Of course, yeah. Yes, unmute your microphones and we can have a chat now, because I think the meeting is sort of come to an end. Just like to thank you all for attending, and also to Izzy for taking the time on a Friday night to come and talk to us. So thanks again for that. And I'll stop the recording now as well.